The network is the de facto transport layer for modern applications. Cloud applications offer significant advantages over traditional desktop software: easier deployments because fixes are pushed to a central location, license enforcement because you control the host, and a proper environment because you provision the hardware. But these advantages come with constraints. Deployments must be made with care. Your server holds sensitive data and may be the only way users can access your application. Enforcing a license means you must guarantee uptime. And supporting all major browsers plus mobile variants adds development complexity. Regardless of how you deploy, there are network limits you should know. Responsiveness is the first one. When a user loads your interface, it's being downloaded from the cloud as they use it. If the network is slow, the interface feels slow even if your server is fast. You can mitigate this by caching the interface in the user's browser using technologies like the HTML offline web application specification. This means the user might occasionally see an older version of the interface, but in exchange they get a fast, local experience. Data access is the second network limit. When a user interacts with a data-intensive feature, part of the perceived slowness is your server collecting from the database and sending it through the network. Interface caching and data caching are different things. Users tolerate an hour-old interface but not hour-old data. HTTPS is a requirement for user privacy, but it reduces performance and the number of clients each server can handle. SSL/TLS adds CPU overhead for encryption and decryption on every connection. This is the cost of security. Accept it as a fixed cost and design your capacity accordingly. Denial of service attacks are a network reality you can't fully avoid. A sufficiently large attack network can overwhelm your servers by exhausting their capacity with fake requests. You can add infrastructure to mitigate and deflect traffic, but some portion of a large DOS attack will always reach you. The GitHub DOS attack from China in March 2015 lasted several days and couldn't be stopped, only partially mitigated. Clients have limits too, limits you cannot control and cannot always predict. Your users may be running an operating system you've never tested, a browser version you don't support, or connecting from a network with extreme latency. The single most important rule when thinking about client limits is, never trust the client. This is not a security paranoia thing, it's a correctness thing. Never trust the user agent string sent by browsers. It can be forged. A laptop can mimic a Nokia phone from any era without any special tools. Don't make behavioral decisions based on the user agent. The link between client and server is also not to be trusted. Always validate information on the server side, even if you've already validated it on the client. If you're using Node.js, you have the advantage that JavaScript runs on both sides. Validation code from your web view can often be reused directly in the server. This eliminates duplicated validation logic. If the validation module is complex, consider using Browserify to share Node.js modules between client and server. Form validation should exist on both sides, not to be paranoid, but to give users a fast feedback loop. Client-side validation catches obvious errors like a text value in a currency field before a round trip to the server. Server-side validation is the authoritative source of truth. Mobile clients add another dimension of uncertainty. Are you prepared for a client on a GPRS connection? Not 3G GPRS, which is extremely slow and intermittent. Do you have a meaningful application experience for a device with a 300-pixel widescreen? A heavy application that renders fine on a desktop will bring a cheap mobile processor to its knees. The device must render all your HTML, CSS, and JavaScript. If that's too much, it will be slow regardless of what you do on the server side. The right approach: build the best interface for your primary target first. Then adapt, not copy, to smaller screens. A task creation app on desktop and a task checklist on mobile are the same data but entirely different interaction models.